Greetings to everyone. In the second part of the lesson, we'll explore creating assemblies and different 3D manipulation options for the objects within them. Let's add any part to the drawing. To do this, click on the Add Component command in the 3D Tools tab, and the selection window will open. I'll select the bracket part. I'll click Open. After selecting the part, a settings window will appear. Using it, we can change the part parameters before inserting it into the assembly. Here, we can adjust the scale of the inserted part for each axis separately, specify part rotation before insertion, and set the insertion point. We can specify it by XYZ coordinates or by clicking certain areas in the graphic space. Select Specify on screen and click OK. Place it in the graphic area. Switch to isometric view and enable the Shaded with Edges display mode. After inserting the part using the Add Component command, a special blue icon will appear in the 3D build history. By expanding the part, we can also see its build history but cannot edit it. If changes are needed in a part included in an assembly unit, we can either open the part file itself and edit it, or right-click on the part and select Edit in Place. We've moved on to the 3D reference editor. If there are other parts in the assembly, they will become transparent and slightly dimmed, making it easier to work with the part being edited. Here, we have the option to change the part parameters. For example, let's suppress the fillet radius. How is the suppress command different from delete? A suppressed element can be easily restored. It remains in the 3D history. By selecting Unsuppress, we can bring back this element. As I mentioned, it remains in the 3D history. It just no longer affects the rest of the part. However, if we delete the component and then save the part, we won't be able to restore it. After suppressing the radii, select the Save Changes command. With the neighboring command, we can undo the changes made, confirm the completion of the editing, and return to the assembly. When changing a part this way, it changes not only in the assembly, but also in the part file itself. Let's add another component to the assembly via the Add Component command. We'll select the square plug and place it in the graphic area. When creating assemblies, it's recommended to fix one of the parts using the Fix command in the 3D history or by aligning it with standard planes and the 0 coordinates, which we'll discuss a little later. After adding all the required components, we may need to set their positions relative to each other using 3D constraints. We'll explore this a bit later. Right now, we'll look at how to change the position of an assembly or part in space using manipulation commands. Aside from simply dragging an object with a left mouse button held down for precise positioning in space, we should use commands from the Manipulators group. Let's start with the 3D Scale command. As you'd expect, this command lets you enlarge or reduce the selected body. To do this, activate the command, choose the desired body, and confirm the selection by pressing Enter. Next, you can choose a base point relative to which the 3D body will be scaled. We'll specify the base point and enter the new scale. For example, 0.5. Thus, we reduced the selected part by half. The next 3D manipulation command is 3D Move. Let's undo the last 3D Scale command because we'll still need the part in its original size. The 3D Move command is for linear movement in space. Activate the command, select the body, and press Enter. A base point and a set of axes will appear. Clicking on these axes allows you to move the 3D object the required distance in space. For instance, you can move it along the X, Y, or Z axis, or within planes like CX, CY, or XY. Let's return to isometric view. The movement direction can be specified by dragging in the graphic area, as I just showed, by selecting the desired axis or plane, or via the command line. For instance, we can select the X-axis and specify a movement distance, like 25 millimeters, This way, we can precisely move the body in space using the 3D Move command, setting the numerical movement value we need. Let's move on to the next command, which is 3D Rotate. Activate the command. Select the body you want to rotate, press Enter, and specify the base point. After selecting the base point, a gizmo will appear. To rotate the body around an axis, you need to choose the rotation axis and specify the rotation angle. For example, I want to rotate the cap 90 degrees around the z-axis. Choose the desired axis, which can be done both in the graphic area and the command line. Select the z-axis and an angle of 90 degrees. As we can see, the part rotated by the specified angle. We can also repeat the rotation command. We can select the rotation axis in the graphic area and set the rotation angle not numerically but visually as we like. Thus, the second part of Lesson 5, dedicated to creating assemblies using external references and commands for moving 3D bodies in space, comes to an end. If you wish, you can practice creating assemblies and moving bodies on your own. When you're ready, move on to the next part of the lesson.